We're ready to open it up to questions for the panel. And while you all are getting ready to think up the questions that you may have, let me open with one or two to begin with. And I'd like to leverage a question, and let me direct this initially to Michelle from Landis and Gear and to Ken from Lockheed, since you all are selling the technologies to the utilities to help them implement smart grid related technologies. How do you make the business case for smart grid? How do you cost justify the grid?
So I think a lot of utilities are looking at, first and foremost, I think this is on, by the way. Yeah, okay. Operational efficiencies as an initial place to build the business case for smart grid. So managing the input of energy and then looking at how they actually manage their metering operations. The second biggest area right now in terms of business case justification is around demand side management and distributed energy resources. Probably more demand side than distributed resources, particularly looking at how the introduction of technologies like Zigbee and home area networking and delivering data to customers through in-home devices and things like programmable setback thermostats will allow them to allow consumers to take control of consumption and start managing that gap between supply and demand. Case in point, I mentioned Texas. Encore Electric Delivery predicted somewhere between 5 and 10% on average, and then when all of the tools are in place for those consumers, including smart appliances, upwards to 20% of reduction in consumer energy bills by building out the smart metering infrastructure.
Ken, what can you add to that?
Well, you know, one of the things that we do, we don't actually sell any physical products to utilities with smart grid. We offer a family of services that are aimed at reducing the utilities' risk and implementing the programs that they've decided to do. Cybersecurity is the top thing. We're probably one of the top 3 cyber companies in the world, and the big concern the utilities had was that we wouldn't give them the CIA or FBI version of it, but they all realize that cybersecurity is critical, and we've tailored products to that. Another thing is there are mandates at every level for utilities to spend this money now. The $8.1 billion that's being invested as part of the AR grant program. Most of the states have said to the utilities, if you don't at least try to get that, don't come to me for rate increases. But large amounts of money have been budgeted for this process, and it's being spent. And I saw the number that Dr. Devon put up. We've seen market estimates that if you look at the total modernization of the electric grid by 2050, it's going to be $7 trillion. And a trillion isn't what it used to be a year ago, but it's still a lot of money. And so our efforts are to help them spend the money toward their strategic directives in the way that gives them the least risk.
Okay, well, let me address a second question, if I may, to our 2 utility executives, Chris Womack and Bob Ray. Where do you see smart grid development and deployment as producing new jobs in Georgia?
The work that will be done to enhance the transmission distribution system, a lot of that will be done through vendors, and so a lot of that will create job opportunities. And so, of course, as we do more work, that will mean more contractors and more direct jobs will come out with that. Of course, with the additional installation of AMI meters, once again, I mean, that's the direct work that will be done by us, it will be done by vendors. And so that already, those are direct and immediate job opportunities that will become available as you install that technology and install that equipment immediately.
Okay, Bob, what's your perspective on that?
I agree totally with Chris. We will deploy 54,000 meters through contractors, which will be a short burst of jobs, which was the intent of the stimulus legislation. Obviously, those end in about 2 years, and hopefully they'll be moving on to other utilities to do work. Internally, it's an interesting dynamic in that the smart grid system is eliminating jobs because we no longer have meter readers and so forth, but we're also creating jobs because of the new engineering technology support staff and so forth that we have to have. So we're actually netting out probably about the same at the end of this program as far as the number of jobs. So it's kind of interesting.
I wonder, though, if it may be, if you're moving to highly skilled engineers managing smart grid operations, replacing meter reader jobs, if you're upgrading in effect the quality or economic impact of those jobs, even if the number of people employed hasn't significantly improved.
Great point. And, you know, we may actually have to be forced to hire somebody from Georgia Tech.
Chris?
As we make the business case for the instance of the leaders, our business case for reduction in new leaders. And so that was the cost of it today. But yes, as we maximize the capability advantage of these systems, there will be additional smart engineers, smart system planners that will be brought on to make sure we maximize these systems. One of the things that we talk about all the time, if we put them in place, let's make sure we use them. Let's not just let them sit there dormant and not take full advantage of capabilities that come along with that. And like I said, we talk about it holistically. And we also look at jobs, and we're going to do units along with our partnership in the state of Georgia. Those are real jobs. I mean, those are subordination jobs that come along with. We look at part of the smart system, which is clean, which is green, which is also efficient. So those are some real full-time, long-range, good things that come along with moving in this direction as well.
Terrific. And then let me address a third pair of questions to Deepak and to Ivan. If you would like to get each of your comments on either or both of these issues, and that is, what do you see as the time frame for smart grid adoption, and which smart grid technologies do you see as most likely to be implemented first as opposed to those that may come on a little further down the road?
I think in terms of which technology will come first, I think it is very clear that at the ground level, AMI adoption is, I think, going to be the first. And you know, if you want to get the consumer interacting in any way with energy decisions, you need that level of interaction. It's not very clear to me whether that is necessarily going to be the utility or it's going to be you know, another venture that kind of aggregates data and you know, provides a service to reduce you know, the energy cost. Because as a consumer, I don't see myself running around the house trying to decide which light should be turned off at this time because it's optimal. I think that's a service. You know, essentially that makes sense. You know, overall, I think as I indicated, it's not very clear to me that just AMI by itself provides enough of an ROI to have a full smart grid kind of functionality embedded into it. I do see that you know, there's got to be some other things in my mind. It's probably a electrification of the transportation infrastructure that provides the strongest economic justification for wide-scale deployment of technology.
I think the time frame is an iterative process, so it depends where you're setting your benchmarks and what outcomes you're envisioning trying to achieve. Because right now, what your desired collective outcomes may be for smart grid, after you go through the first iteration of implementing the first technologies to move toward that outcome, it's going to accelerate a learning process, and there's going to be data and information. And that's going to drive some realizations and hopefully in the utility and private sector to open up some new possibilities. So with all of the pressures and risks of carbon regulation and all of the opportunities in electrifying transportation, bringing more distributed generation onto the grid, and also the economic opportunities of trying to make sure that everyone actually is a producer into the new global energy economy, not just a consumer, which is a very heavy economic development challenge for the Southeast in particular because it's playing catch up to other parts of the U.S., Europe, and Asia. But we can do it. So my answer is, and this is the world I think in, the technology doesn't matter to me. What matters to me is the outcome. That there's a clear structure for learning and sharing knowledge, and that it does continue to drive innovation and adoption. So there's got to be a societal framework for that, and so your leaders would be should be voted out of office if they don't provide that for you, and are not responsive to you as you deliver your ideas on how to do that, because they're not preparing your economy for the global energy economy.
All right, but let me put you more on the spot, but ask any of the other panelists to contribute your thoughts, if you may. More specifically, as you look at whether you want to look at it in terms of adoption of specific technologies or provision of the benefits of smart grid capabilities across the range of those that have been discussed today. If you look out, where are we talking about seeing some of these incremental kinds of implementations and improvements? 2 years, 5 years, 10 years? What are we talking about here?
Well, I think you have to see it now, Jack. You know, I've got a brand new grandson up in Marietta, and
congratulations.
The world to live in if we don't deal with this now. And we're fortunate that the federal government is providing a lot of funding. The utilities are providing a lot of their own funds. As several people have said, this didn't start last week. The utilities have been planning for this and investing in this for years, but we've got to step it up. We can't deal with renewable energy the way we need to yet. We aren't building electric cars at work yet. We don't have any place to plug them in and charge them if they were around here yet, and we've got to get on with it. The biggest lesson I think I've learned in the last month, and it was something we suspected all along, and now we've seen it on TV, and that's consumers in California and other states standing outside the utilities with pitchforks in their hands saying, why am I spending $350 a month on my electric bill to have a smart meter and my bill is going up? And the reason is we didn't do the whole job. We didn't put intelligent devices in the home that allow the consumer to engage and manage their electricity. So it's not a point problem. You can't put in these and see how it goes, and put in those and see how it goes. You have to invest in a big way and put in end-to-end systems to solve the whole problem, as painful as that may be financially, or you're going to do more harm than good.
Further comments before we open it up to the audience?
So let's keep it. Oh, sorry.
Now, this is a technology, but don't forget the customer. Do not forget the value proposition that technology brings to the customer, because the customer's got to accept and got to pay for it. And so we can't just be excited about technology because it's fun and cool and geeky and all that cool stuff. You've got to keep the customer at the center of your virtual office, or else it will be rejected.
I absolutely agree, and I do want to add there are some real examples today where we're seeing positive impact because a holistic view was taken of the whole system deployment of customer education. In 3 years' time, there will be 3 million home area networking enabled smart meters deployed in the state of Texas under Encore Electric Delivery. They have spent hundreds of thousands, if not more, dollars on early and often consumer education programs. We contributed in building out a mobile experience center, which is driven around all of the areas under the Encore Delivery umbrella, having technology information days and energy awareness days and Home Depot parking lots and Lowe's parking lots across the state of Texas, so that consumers understand when their bill comes what's happening. When someone calls them and says, let's talk about getting on a particular rate plan so I can give you time of use rates. Let's talk about putting a smart thermostat in your home, that consumers get it. So I don't think that it's 10 years down the line. I think it's today, and I think we see active deployments. There's been almost 10 million smart meters installed here in the year of 2009 across the entire industry, and we're going to see that number climb and climb in the coming 5 years or so. So I don't think this is many years down the road. People are successful today.
Great. Deepak?
One comment on this. I think I really agree with you in that if we just do what we are saying we're going to do, if we put in place RPS mandate, if we put in place carbon cap and trade, if we put in place all the other things, only one thing's going to happen, and the cost is going to go up, and everybody's going to be up in arms about it. they're going to say damn the world. I mean, I always say if you have a choice about saving your family and saving the world, which one are you going to save first? It's, I don't think there's any question about it. And I think, by focusing too much on, let's implement, we're not finding the cost offset. I think it's absolutely critical that we, at a societal level, identify those areas from where the cost savings is going to come, put them first. Put the policies in place that allow those to move first, and the rest will fall into place. If we push this technology out, I think there's going to be bad repercussions.
Okay. Ivan?
Actually, maybe we should stop running with this over here, but that's intentionally what we did in North Carolina with some of our policies, is we said this has to be manageable from a cost perspective. So our state purposefully bundled energy efficiency and renewable energy distributed generation technologies into the same policy in 2007 because the higher cost of renewable energy needed to be offset with the lower cost of energy efficiency. And the way it netted out in the state government's analysis was that over the next 10 years, if we transitioned our state generation portfolio or retail sales of electricity from its status quo, took 10% of it and moved it into renewables and efficiency, it would cost $500 million less in 20-year net present value for the state. We had been working from all sorts of assumptions and beliefs that were counter to that result of the analysis done by our regulators. So it was very important to stop and ask that question: can we offset the cost of this next incremental improvement with technology that can then yield these other benefits in jobs, economic development, health, environment, and so on and so forth?
Okay. Bob, care to add to that at this point?
Amen.
Okay, good. Well, at this point, let's open it up to the audience, and I see a hand in back of the gentleman in the black shirt.
Hi, I'm Jeffrey William Cisco. My question is, in terms of customer outages, for example, brownouts, how have those been traditionally managed, both inside the power generation plants as well as when the neighborhood goes down, bringing the neighborhood back up? How's that been handled traditionally, and how is that being impacted by these smart grids to make that better?
And so everyone can hear it and we can pick it up on the videotape. Let me attempt to repeat the question as accurately as I can. In terms of customer outages, brownouts, and so forth, how has that traditionally been handled, and how will the impact of the smart grid change the ability to manage that more effectively? Is that essentially the question?
Yes.
Great.
I would hope we're going to be a lot more efficient. I think we're very good now when we're starting the outages as the local utility company. One of the premises is, as a result of smart grids, smart grid, smart technology, all the different systems in place, communication, you can close breakers, open breakers, you can operate the system, audits will be automated, so hopefully those outages will not last, the duration will not be as long as they would normally have been. At the same time, we know we have a better sense of where the outages are, so we know where to dispatch our crews. So the premise is we will be more efficient in responding to outages, and so we hope that will be the case. And we think we're pretty good now as we look at the frequency of outages and the duration of outages. Hopefully with this technology, those durations will be a lot less than they have been in the past. So that's the major premise and the major objective of installing this technology.
Okay. Additional comments?
Just only reinforce that. First of all, I would say as a customer of Southern Company and Oglethorpe Power, we don't have brownouts. That's not an option. The systems that are in place and the other EMC in the state that will be doing a demonstration project, which is Snapping Shoals, is actually going to investigate, along with Georgia System Operations, the whole concept of self-healing technology that will recognize the outages and switch to other resources. Exactly what Chris is saying. So it's not something we've had an issue with, and I think we're only going to get better. Georgia has some of the best reliability ratings in the nation, and we're proud of that. We're only going to get better.
Okay, next question. Okay. Who'd like to tackle that one?
I think the question kind of spanned a number of areas. Let me try to see if I can respond. Texas was a very interesting case in point. I mean, it kind of points to challenges in terms of the way utilities operate. As far as I understand, there was wind forecast available, which pointed to the fact that a front was coming in and the wind speeds were going to get to a point where the turbines were going to start shooting out, and you're going to see a substantial drop in power. So that forecast was available to some operators, but they're not used to looking at that and making the projections. So they didn't tie all the ends together, and suddenly, we're hit with a drop in generation capacity. I think what it again points to is the smartness of operations that are required. So, as you are beginning to integrate, I mean, Jim Denver from California, I just said it well, he said 10-15% penetration we know how to handle. 20%, we started to get really sweating, and 30% we have absolutely no idea how to do it. And I think that's reasonable. And we're looking nationally at RPS mandates that are started to approach 20%. So there's a lot of new knowledge in terms of dispatching these resources as the power flushes back and forth. How do you handle it? How do you price green electrons preferably? I mean, these are all challenges I think that no single institution is going to handle. We have significant programs that we're working on in collaboration with government and collaboration with the RECA and a lot of utilities, and hopefully these will all begin to make a place. The challenge is not just technology development, but really creating a cadre of people who are now trained in managing and in operating these technologies, and that's probably a bigger challenge than what we have right now.
I would say the opportunity for Georgia is similar to the opportunities in North Carolina. With so much expertise in smart grid in Georgia, is to take those services to the markets where grid stability and reliability is a concern because of distributed generation penetration. In the Southeast, no state is close to it being a concern unless we're in a situation somewhere on the grid where we're just in time. It's just so old that it's going to be a concern no matter what you put on it. But our penetrations are so low, and I think that's part of the learning process that we're seeing in other states. Colorado and New Mexico, the utilities are now coming back and wanting to charge a fee on solar, on customer generators of solar, because the penetration levels are getting high enough that they're starting to experience cost of being experienced people. I think that's part of the learning process and the cost of learning, and they're trying to recover that cost of learning. And to an extent, customers have to, I think, be engaged in a dialogue that brings them to a point where they're willing to pay for some of that cost of learning for the benefit down the road as well.
We have time for one more question. Okay, this gentleman here is down toward the front.
My name is Wahab Ruben from the electric company. I just want to know that everybody is talking about smart grid, for technology. So, who will be the winner? It will be the technology, or it will be the psychology to change the consumer behavior?
So who will be the winner? The technology supporters, or is that right, or those who are?
Well, I'm sorry, Chris. Yeah.
I mean, the customer's got to be getting a better product, a better service, a product that matches what their needs and demands are. And I think to view it any other way, I think we're going to get ourselves in really trouble. Okay?
Yeah. I'm sorry, go ahead.
I agree. I think the customer has to be the winner, or else we all lose. But I think customer winning has to be viewed in more than did my energy bill come out lower or not. Sure. If my children and my grandchildren have a much worse future because I enjoyed 6 months of lower energy prices, I lose. Okay, so I think we really need to figure out a broader way of looking at this more holistically.
Yeah, I think the other thing too is that they're inextricably tied. Every problem that our customers have now and that they see ahead of us technology may or may not be able to solve it, but it can make a big dent in it. The issue with the wind farms just now, the folks in Texas are spending $3.2 billion to run new high-power transmission lines from the wind farms in West Texas to the cities in the central part of the state, and that's using some new technology that didn't exist 3 years ago. We're working with utilities out west to use LIDAR, which is a technology we developed to find wind bursts at airports, to be able to predict as much as 3 hours in advance when there are going to be significant changes in wind. And we're using carbon nanotubes to make the vanes on wind turbines much lighter and much stronger, so that they can run at much higher speed and with much more variability, and they don't dent quite so much when they hit the birds.
One thing to look at in your state policy is on what criteria do you expect your electric utilities to provide 100% reliable electric service? And those criteria can affect cost. So in North Carolina, we're starting to realize in our dialogue that we only have two criteria, least cost and reliable. And our utilities are expected to meet that no matter what. The problem with least cost that we're realizing is that we're applying that on a case-by-case, proposal-by-proposal situation instead of taking a more holistic look at the entire portfolio. And what's happening then is the least cost in cents per kilowatt hour is resulting in a higher total energy bill. And this is part of our learning process where we're realizing there are things that aren't making it into the mix, proposals that aren't coming forward, such as smart grid or energy efficiency, because in our policy, because we're so focused on least cost, tailored to large central station generation proposals, we're not affording our electric utilities appropriate cost recovery from their customers and the appropriate incentive structure for them to incorporate energy efficiency and smart grid into their business model in a way that can deliver lower than what would be cost. They're all going to go up, but to minimize what that cost increase is in the future by looking at total energy cost instead of least cost cents per kilowatt hour.
Michelle and Bob, any final comments you'd like to offer? No? In that case, I have a couple of closing announcements, but before I do that, how about a hand for our panel?